All right, let's review 3.10 trigonometric equations and inequalities. This video is about equations. The next video will be about inequalities. All right, okay. I'm going to show the process of two questions, and I think that should clear everything up about how to solve these questions. Okay, let's start with sin x equal to root 2 over 2. In fact, okay, fine. Let's start with sin x equal to root 2 over 2. That's question number A, and question number 1. And I want to take a negative number as well. Let's take tan x equal to negative 1. So that's question number 4. Tan x equal to negative 1. Okay. See, earlier we have already discussed the sign of trig functions in various quadrants. If you remember, we talked about all students take calculus. Or A means all trigonometric functions are positive in quadrant 1. S means only sine and cosec are positive in quadrant 2. Only tan and cot are positive in quadrant 3. And only cos and sec are positive in quadrant 4. So if sin x is equal to root 2 over 2, and notice that they only need the solution from 0 to pi, it definitely means that our answer is either in quadrant 1 or in quadrant 2, because these are the only two quadrants where sign is positive. Now, even if there is a negative sign, you just ignore the negative sign, which we will do in question 2. Here, root 2 over 2. So think about in quadrant 1, which angle gives root 2 over 2? Sin x equal to root 2 over 2, that's pi over 4. And once you have a reference angle in quadrant 1, you can easily swing this angle. What is its corresponding angle in quadrant 2? So its quadrant 2 angle will be pi minus pi over 4. So that's where I want to write this, that if theta is a quadrant 1 angle, then its quadrant, if we swing this in quadrant 2, it will be pi minus theta. If we swing this in quadrant 3, it will be pi plus theta. And if we swing this in quadrant 4, it will be 2 pi minus theta, right? So here pi minus pi over 4, which is 3 pi over 4. So this is my answer, pi over 4 and 3 pi over 4. So this is pi over 4 and 3 pi over 4. Okay, what if the angle number is negative? That's fine, just ignore the negative. Think about where is tan x 1. Tan x is 1 when x is pi over 4, but they need negative 1, and tan is negative in quadrant 2 and 4. So how to swing this reference angle in quadrant 2? We just talked about it, pi minus pi over 4, and in quadrant 4, 2 pi minus pi over 4. So the answer is 3 pi over 4 and 7 pi over 4. That is the answer to this one, 3 pi over 4 and 7 pi over 4. So if you understand this, you should be able to solve all such questions. So cos x equal to 1 over 2. 1 over 2 is in pi over 3. Cos is positive in quadrant 1 and quadrant 4. And quadrant 4 swing will be 2 pi minus pi over 3, which is 5 pi over 3. Okay, pi over 3 and 5 pi over 3. The next is cos x equal to 0. So for this, you just have to understand that cos 0 is when x is equal to pi over 2, and then x is equal to 3 pi over 2. Over here, the unit circle will be helpful for you, pi over 2 and 3 pi over 2. Tan x equal to root 3, tan x is root 3 when it is pi over 3, and a quadrant 3 angle will be pi plus pi over 3, which is 4 pi over 3. So this is 1 and this is 2 values. Likewise, tan x, sin x is, and okay, here we need to solve for all solutions. This one was for 0 to pi, and this one was for, this is for all solutions. So I'll tell you how to find for all solutions. Almost, in fact, 80% process is same. 80% process is to find those two values in 0 to 2 pi. For sine and cosine, for tan there is a slight change, but let me work for sine and cosine. So for sine, just in a usual way, find the two angles, which will be pi over 3, and I think quadrant 2 is pi minus pi over 3, which is 2 pi over 3. And once you get these angles, just add a 2k pi to it. And 2k pi just means that k is any integer. So k can be 0, 1, 2, 3, 4, -1, -2, -3, -4, and so on. So both these are the general solution, or so-called all solutions of this equation. However, for tan, the only difference is you will find only a single angle. For example, a single angle in either quadrant 1 or quadrant 2, whichever is applicable. For example, here tan x is 1. So you will find only x equal to pi over 4 and then add k pi to it, not 2k pi. It was 2k pi because the time period of sine or cosine is 2 pi. But the time period of sine or period of tan is pi only. That's why we add k pi. That's it. Likewise here, tan is 1 over root 3 when it is pi over 6, but we need to find a quadrant 2 angle, obviously where it is negative, so it's pi minus pi over 6, which is 5 pi over 6. So the answer will be 5 pi over 6 plus k pi. Right, that's the difference for tan. For tan, well, sine or cos just behaves in a similar fashion. So for example, this happens in pi over 4 and a quadrant 4 angle, which is 7 pi over 4, and we just add 2k pi. 2k pi. Sin x equal to -1, I think happens only at 3 pi over 2 in 0 to 2 pi, right? 3 pi over 2. So we just add 2k pi to it. Root 3 over 2 happens. Root 3 over 2 is in pi over 6, but we need a quadrant 2 and quadrant 4 angle. So it will be quadrant 2 and quadrant 3 angle, which is pi minus pi over 6 and pi plus pi over 6. So this will become 5 pi over 6 plus 2k pi, and here it will be 7 pi over 6 plus 2k pi. That's the answer. Right, likewise, this just involves a little bit of rearrangement. For example, over here I have 2 cos x equal to -1. So cos x equal to -1 over 2, and we need all solution in 0 to 2 pi. So we have a solution in quadrant 2 and quadrant 3. The reference angle will be, I think, 60° pi over 3. So the quadrant 2 angle is pi minus pi over 3, and quadrant 3 angle is pi plus pi over 3, which is 2 pi over 3 and 4 pi over 3. All right. Over here, we divide both sides with -4. So sin x will be negative root 3 over 2. Sine is negative in quadrant 3 and quadrant 4. The reference angle is pi over 3. So quadrant 3 angle will be pi plus pi over 3, and quadrant 4 angle will be 2 pi minus pi over 3. So this will be 4 pi over 3 and 5 pi over 3. Okay. What are the x-coordinates of the point of intersection of f and g in 0 to 2 pi? So point of intersection just means that when both the functions are equal, right? So you have to solve for fx equal to gx basically, which means that 5 minus 3 cos x should be equal to 5. So 5 and 5 is gone, which means that minus 3 cos x is 0, which means that cos x is 0, which means that x is equal to pi over 2 and x is equal to 3 pi over 2. So pi over 2 cos pi over 2 is 0, and cos 3 pi over 2 is also 0. Okay. Right. Likewise over here, we have to equate both. So we have 6 plus 4 sine x is equal to 4, which means that 4 sine x is equal to -2, which means that sine x is, dividing both sides with 4, we have -2 over 4. So this means that sine x is -1 over 2. So if sine x is -1 over 2, that happens in quadrant 3 and quadrant 4. Reference angle is pi over 6, which is 30°. So pi plus pi over 6 and 2 pi minus pi over 6. So this comes out as 7 pi over 6, and this comes out as 11 pi over 6. These are the two answers. Likewise over here, this is tan x. So fx is equal to gx, which means that 3 plus root 3 tan of x is equal to 4, which means that root 3 tan of x is equal to 1, which means that tan of x is 1 over root 3. Okay, so tan x is root 3, which means that that happens in quadrant 1, that is pi over 6, and that happens in quadrant 3, which is pi plus pi over 6, so 7 pi over 6. What are the zeros of g? Zeros means where the function g is 0, right? So function g is 0 when 2 minus 4 cos square x is equal to 0, which means that 2 is equal to 4 cos square x, which means that 4 cos square x is equal to 2, which means that dividing both sides with 4 cos square x is 1 over 2, because 2 over 4 is 1 over 2. So be careful, when you take a square root both the sides, you won't just end up with 1 over root 2. You will end up with plus and minus 1 over root 2. So you'll have two solutions here. One from cos x equal to 1 over root 2, which means that you will have pi over 4 and a quadrant 4 angle, which is 7 pi over 4, right? 2 pi minus pi over 4. And two angles in the from cos x equal to negative 1 over root 2, which will involve quadrant 2 and 3. So pi minus pi over 4, which is 3 pi over 4, and pi plus pi over 4, which is 5 pi over 4. So these are the four solutions that we have between 0 and 2 pi. All right. Again, we need to find the zeros of h. So zeros of h would mean that 2 sine square x plus sine x is equal to 0, which means that sine x 2 sine x plus 1 is equal to 0. If the product of two, zero product property, the two entities is 0, then either the first one is 0 or the second one is 0. Okay. So sine x is equal to 0. This means that x is either 0 or x is either pi. I won't say 2 pi because 2 pi is not a part of the domain. These two are the answers. And sine x, 2 sine x plus 1 equal to 0 means 2 sine x is negative 1. So sine x is negative 1 over 2, which means that the value of x is the reference is pi over 6, so quadrant 3 angle will be pi plus pi over 6, which is 7 pi over 6, and 2 pi minus pi over 6, which is 11 pi over 6, because sine is negative in quadrant 3 and 4. Okay, likewise over here, find all the values of theta for what cos squared theta is cos theta plus 2. Okay, this is an interesting question. I want you to pay attention here. Because this has a square term of quadratic and a quadratic as well. So there's a special way that we can convert this into a regular quadratic by substituting, let's say, cos theta temporarily as as a variable. Let's say x. So x square is equal to x plus 2, which means that x square minus x minus 2 is 0. And this can be easily factored, right? From our earlier knowledge of algebra, x minus 1, x minus 2, x plus 1 is equal to 0, which means that as per zero product property, x is equal to 2 or x is minus 1. What is x? X is cos. So cos is 2 and cos is minus 1. Guys, is cos theta equal to 2 even possible? No, because the maximum value of cos is 1. So 2 is not possible. So no solutions from here. This is possible at theta equal to pi. This is the only solution between 0 and 2 pi where cos is negative 1. Okay. Likewise over here, we need to find the point of intersection, which means that 2 sine square x is equal to negative root 2 sine x. Let's move everything on one side. So 2 sine square x plus root 2 sine x is equal to 0. Sine x is taken as a common factor. So 2 sine x plus root 2 is equal to 0, which means that either sine x is equal to 0, which definitely means that either x is 0 or x is pi, or 2 sine x plus root 2 is equal to 0, which means that 2 sine x is equal to negative root 2, which means that sine x is negative root 2 over 2, which means that x is equal to okay, the reference angle is pi over 4, so I need the angles in quadrant 3 and quadrant 4, which means that pi plus pi over 4, which is 5 pi over 4, and 2 pi minus pi over 4, which is 7 pi over 4. So these two are the solutions. Okay. The next one is 4 cos cube x is equal to 3 cos x, which means that 4 cos cube x minus 3 cos x is equal to 0, which means that cos x is taken out as a common factor. We are left with 4 cos square x minus 3 is equal to 0. Okay, so zero product property, either cos x is equal to 0, which means that x is either pi over 2 or 3 pi over 2, or I'm running out of space here, or this one is equal to 0. So 4 cos square x minus 3 is equal to 0, which means that 4 cos square x is equal to 3, which means that cos square x is 3 over 4. And if we take square root both the sides, I have plus minus square root 3 over 4, which means that cos x is plus minus root 3 over 2. Okay, so from here I have two solutions. One is when cos x is root 3 over 2, and that happens in pi over 6, quadrant 1, and quadrant 4, which is, I think, 11 pi over 6. And then I have cos x equal to negative root 3 over 2. That happens when x is in quadrant 2 and 3. So pi over 6 is the reference. So it will be pi minus pi over 6, which is 5 pi over 6, and pi plus pi over 6, which is 7 pi over 6. So these two are the solutions as well. So I think we have 1, 2, 3, 4, and 5 and 6. 6 solutions in total. Right. Last question. Again, I think rinse and repeat. That's the same situation. Although the function is x this time. So, oh, there's a negative here. Tan square x equal to negative of tan x, which means that tan square x plus tan x is equal to 0, which means that tan x plus 1 taken as a common factor, tan x equal to 0, which means that either tan x is 0 or tan x plus 1 is 0. And tan x is 0 when x is 0 and x is pi. It is 2 at 2 pi as well, but 2 pi is not included in the domain, so that's not my answer. This one is when tan x is negative 1, which means that x is in quadrant 2 or quadrant 4. So quadrant 2 solution will be reference as pi over 4. So quadrant 2 will be 3 pi over 4, and quadrant 4 will be 7 pi over 4. So there are 3 answers to this question.